So our next speaker is Matthew Davies, who's going to be talking about alarms. As I mentioned, there will be a fire alarm in the middle of this presentation. Also, a timely reminder from someone, because I forgot. Can you turn your mobile phones off, please? Thank you to whoever reminded me. So Matt is the Business Development Manager for Digital Products and Services at Memco, which is a brand of Avaya. In addition to his responsibilities at Memco, Matt is a member of the BSI Committee MHE4, SEN TC10 Working Group 1, responsible for revising EN 81 Part 28. Prior to joining the lift industry, Matt worked in the semiconductor industry, specialising in solid-state lighting. Matt, thank you.
Good morning, everyone. So my presentation today is about the evolution of lift alarms in the UK. And it's worth talking about, obviously this is something I'm interested in. I work for an alarm manufacturer. But the real genesis of it came from some common questions we were getting from building owners, which began with, why do I need a voice alarm? Which from within the industry seems very obvious, but is obviously problematic for some building owners. Why can't we just fit a bell? So there was still the desire to fit the alarm bell. And my personal favourite from last year, could we fit a louder bell? So it then led to me looking back in the British standards and going through the codes and standards to understand what's been our philosophy on this and what's ultimately been our culture in the UK of how we've delivered alarms onto lifts. Sadly, I don't have any photos of this, but Memco also did a site survey back in 2016 at a hotel in Norfolk, where at the time, their method for a trapped passenger to signal for help was a trap door that you opened, reached and grabbed a rope, yanked on the rope, and it rang a bell on the top of the lift, which I suppose was indeed an audible alarm when the lift was first put in, but in 2016, it felt like it was old hat. So I started at the beginning, and I went back and I found a copy of the 1935 Code of Practice. And I was interested by what I found here, because we had the requirement under lift cars for an automatically operated lifts. So there's still the, in this code, we're still talking about automatic lifts and those with an operator in them. But there is an requirement for an alarm bell or a telephone circuit. So the need for a voice alarm has been in since 1935, which shocked me because, and I've only been in the industry 10 years, so I appreciate I'm very much the new boy in this room. There's this vision that we've only needed voice alarms since the late 90s, but back as far as 1935, it's been a requirement. Looking then at the 1943 code, we see really the same requirement, but slightly different language. I think it's becoming more like the standards language we would expect today. What's interesting here is there's no further guidance in either of these versions on instructions for how to operate either device by a trapped passenger. And it does make me wonder if this is also the start of what the fire service referred to as nuisance calls from trapped passengers. Because if all you've got is a telephone, you may well dial 999. So the fire service may have been pulling lift doors off since the 1940s. It's important as well, while I'm telling this story, to also talk about the telephone network in this country, because the two things are inherently linked. As soon as you're provisioning a telephone, you are reliant on the telephone network for what it's going to do. So rather than going through a 140-year history of this, I will be very brief. The telephone network in this country has been provisioned really in two ways. State-owned near monopolies. So we started with the General Post Office in the 19th century. That ran into the 1970s when it became Post Office Telecommunications. State-owned, not quite a monopoly, because Kingston upon Hull, for historical reasons, was always allowed to be separate. Ultimately privatised in the 1980s and the birth of British Telecom, which we still have today. Kingston upon Hull, not privatised until 1999. But our public switch telephone network was built, like all of them were built, as a series of copper cables interconnecting telephone exchange buildings with premises, be they private or government premises. Began entirely manually. You see a picture here of a manual exchange with the operator there, and the operator is physically making connections for calls being placed. meaning a trapped passenger would pick up a phone and would probably, to begin with, speak to one of these people and ask to be connected to whom we're not sure. The important piece with all of these networks, though, was that the copper network carried its own power. So there was nominally 48 volts DC on the line, so what we would call line power. This was separate from the national grid. So the telephone lines always exhibited power autonomy. And it's interesting because later codes pick up on this, and even today there are things we do which have an inbuilt assumption that that power will be there. So going back to the codes, I found a copy of the 1957 code, which was almost unreadable. And then I found a copy of the 1958 code, which was almost unreadable because they're essentially old photostats. What we've got here really is a repeat of the 1943 language, pretty much unchanged. And this text remains in place through the 57, 58, and 70 versions of this. Now, at this point, I'd like to make some acknowledgements specifically to Mr. Gordon Lucas and Mr. Kevin McNulty, who gave up some of their time to talk to me and really walk me through what common practice was in the lift industry. And this is very much the age of the alarm bell. Alarm bells were essentially the standard approach. Some local authorities would specify an additional bell placed on the landing or somewhere else in the building. And at this time, you had a lot more building staff still in place. The first generation of council tower blocks that were built were usually built with a block warden being someone who was permanently on site. If you go into a council tower block today, you may see a boarded up supply cupboard on the ground floor. That used to be the block warden's office. So there was always someone around, or the theory was there was someone around to hear the bell and to know what to do when they heard it. The other interesting thing at this point is picking up on something which is still a problem with lift alarms today, which is misuse. Obviously, if you have an unprotected telephone in a lift car, enterprising lift passengers may start to explore this. And I shared a number of stories of absolutely horrified local authorities and building owners who had telephone bills for several £100s because someone's placing a long-distance telephone call from inside the lift. This then led me to look at what were these telephones in lifts, which led me to the BT archives in London. And they have an archive of, essentially because BT was once state-owned, they're obliged to keep everything they've ever done. And I was able to unearth this telecommunications instruction document from the late 70s. This is somewhere between a specification and a work order, I would say. Entitled Telephones in Lifts, it outlines the types of telephones installed and the division of responsibility between a lift contractor and what at the time was Post Office Telecommunications. So as lift contractors, the responsibility was essentially maintain the trailing flex, so the connection between the lift and the outside world. The Post Office would then provide and maintain the remainder of the installation. And I've reproduced there one of the pictures showing I hope all of us remember rotary dial phones, I certainly do. A rotary dial phone in a recess. There were two options for these, as you can see there, depending on the size of recess you had. And it was what was called the old 700 type rotary dial phone. With regards to this recess, as I was reading this, it is specification language, it is performance language, but having dealt with BT in the past, I could only read it one way, which was that lift manufacturers must agree to provide the recess in the lift car, and only in exceptional circumstances will anything else be considered. Post Office were at least willing to provide the doors and the panels for these covers. But you can see here, this is just a standard telephone, hopefully with some instructions printed on the inside of that door. So we come to the end of the 1970s and the publication of BS 5655. This was the first time that we also adopted a European standard. So in the UK, this is our first time we have EN 81 Part 1 come in. I'm not going to read all of that requirement because we really are into the world of standards languages now, but the bits to point out here is the emergency device could still be in the form of a bell, an intercom system, an external telephone, or similar device, whatever that might be. So we can still put alarm bells in, but we've also now got in-building intercom and external telephone. The real change, though, are these two clauses, which are the requirement for a form of backup power. Now, these are interesting because the first one has us powering the device from the emergency lighting supply. This was a bit of a eureka moment for me, because one of our number one tech support calls, and it was the bane of my life when I was a product manager, was the Lift auto dialer has drained its battery and we don't know why. At the time this was written, the lighting supply was required to have a 1 hour power backup on it. So a generation of Lift engineers are trained to take the emergency alarm device and connect it to the lighting supply. The problem with this is eco mode comes along at some point. So even today, people are connecting to the lighting supply, eco mode kicks in, the lights switch off, and our device happily drains its battery. No one can work out why until we go to site and say, have you connected this to the lights? Yes, that's what I've always done. Why is it a problem? Are the lights on eco mode? Oh. The other bit here, and we hark back to the power autonomy of the telephone network, because it says that in the case of connection to the public telephone network, we don't need to put a separate backup in. So at this point, the assumption was you are drawing your power from the telephone line, and that telephone line will always be there. This pervades a number of codes today because this still exists in some of the ancillary codes around platform lifts and so on. I will talk later about why this is increasingly not the case. This is also the point where we see the emergence of what we would understand as the Lift auto dialer today. There was a variety of reasons why auto dialers were developed, which are too numerous to go into here. But it reduced the problems of misuse around telephones, because an auto dialer is pre-programmed to dial 1 numbers or a sequence of numbers. So a trapped passenger pressing the button can only ever speak to the rescue service on the other end. They cannot place a long-distance telephone call to their relatives. It also means that the trapped passenger needs very few instructions. Press and hold the alarm button. You also see the emergence here of the Lift alarm starting to merge with... interrupted by, indeed, an alarm bell. You start to see the emergence here of the auto dialer being merged with other systems, so specifically the first generation of lift monitoring systems, which can use what's called dual-tone multi-frequency signaling, aka touch-tone signaling, to pass information over the telephone network about ultimately lift status and so on. So, coming towards the end of our story, in 1997 we have the lift regulations brought in. These require any lift being placed onto the UK market to have a two-way means of communication and must be constructed so that they can operate without the normal power supply being in place. We then have the 1998 version of EN 81.1, and this is the end of the alarm bell. The alarm bell is no longer an acceptable requirement in here, and it has to be a two-way voice communication system. So if you're asked by a building owner, how long have we needed voice alarms for? Since at least 1998. We still have the same power requirements here, and we're still allowed to use the emergency supply from the lighting. Our next big change, though, is in 2003, and anyone who knows me knows how difficult it was for me only to put one slide in about part 28. Not going to go through this document. It's a dedicated lift alarm standard, but the biggest changes here were the requirement that the backup power be part of the alarm system and not drawn from anywhere else, but it's also the introduction of the 3-day test call. So the alarm has to dial out every 3 days, essentially as a proof of life. I can dial out, I'm working. It has to be dialing out because dialing in doesn't prove your call chain. I constantly get asked this, why every 3 days? It is a particularly macabre reason, but the reason is a human being can survive for 3 days without drinkable water. So when we talk about the call being every 3 days, it is based on the assumption that somebody is stuck in there for the full 3 days without water. A particularly unpleasant thing to think about. Most designs use that same DTMF signaling to place and register their test calls. So, slipping back quickly to the telecommunications network, how's that changed around us? One of the big changes, of course, was the introduction of mobile telephony. So 1985 is the beginning of mobile telephones in the UK. This is indeed the 1G. There was a 1G. Experimental systems had been around for a long time. The post office had experimented as early as the late 50s, early 60s with this. But it's really in the early 90s with the Global System for Mobile Communications, that's where we get the GSM acronym from, being introduced, that we really see the widespread adoption. The lift industry very wary of adopting this technology. The lift installation is absolutely a signal hostile environment. We have a lot going on between our steel guide rails, our concrete shaft walls, our love of fluorescent lighting gear and so on, that will interfere with those. Early adoption of this was as a temporary measure. You've fitted the lift, you've put the compliant lift alarm in, where's the BT man to connect the line? Because I can't hand the lift over, we'll stick a GSM in while we wait for him. Adoption of this technology really accelerated in the 2010s, however. A lot of this was economic. SIM cards were a lot cheaper than landline rentals, but there was also a lot of improvements around signal reception and signal retention, the ability to reach out, get a signal, hold on to it. Also, it meant the whole alarm system, the alarm and the connection, were now the responsibility of the lift contractor. As we come to the end of this story, though, the biggest change that we are facing now is the end of the public switch telephone network. After 140 years, it is going away. The copper landline of 1935 is in many ways very like the copper landline of today. However, final closure of the copper network is now January 2027. The PSTN cannot handle our desire for data. Older equipment is becoming too expensive to maintain. And something that I think our industry can be sympathetic towards, the last generation of telecoms engineers trained on analog equipment are now leaving the workforce. What does it mean for our industry? We will ultimately lose the DTMF signalling that we rely on today for a lot of things we do, but fibre optic cable cannot carry power. The landline network is now reliant on mains power within the building. So where does that leave us? 89 years on from the first code, the vast majority of that time, the telecommunications landscape was largely unchanged. What we did in 1935 would still work today. The PSTN closure massively changes that. Mobile networks are also now beginning to retire their older technology. 3G has been and gone in the space of 20 years. Of the 300,000 passenger lifts in the UK, there's varying estimates, but we think it could be as many as 250,000 still sat on landlines. That landline will change how it operates in the next few years. So innovation is needed in design and also implementation of lift alarms, both new product coming out of factories, but also everything we have in place today. It needs to be looked at, and we need to understand how that can carry on working for the time when a lift passenger may most need it. Thank you very much. Any questions?
Thank you, Matt. Just a piece of trivia. The longest someone's been stuck in a lift in the UK is 62 hours. And it was a bank holiday weekend, last guy in the building, leaving, and got stuck in the lift. That was a guy called Graham Coates in Brighton. Adam.
Hi, Matt. Adam Scott from Swaco. Great presentation, thank you. You mentioned where you moved to GSM that everything comes under the control of the lift contractor. We've got projects in central London where the lift contractor has installed a GSM system and is unable to hand the lifts over because the signal is not strong enough because of the surrounding buildings and the installed environment and the mobile reception network. And we're now in this kind of impasse situation where they're saying we've got a big issue here, and I'm just keen on your thoughts on that.
This is becoming one of the most difficult areas, and it's interesting that planning regulations specifically in London are starting to change around not only can you no longer block someone's line of sight, you also can't block their signal by building a building next to it. I think this is one of the key areas where we need to see innovation. And it's also going to be, I think, the next friction point between the lift industry and the rest of the building. Because depending on where the lift is sited, and I'm going to a site visit in a few weeks' time right opposite a radar tower at Heathrow Airport, so probably the worst signal situation we can get to. And we are going to need to talk there about potentially cabling back through the building. Certainly we've done jobs and we've had conversations about cabling to the roof at times. But I think investment in understanding around signal repeaters and also the potential risk that things like signal repeaters bring in. I've battery backed the lift alarm, I've battery backed the gateway. If you now buy a signal repeater off Amazon, plug it in and hope for the best, we have a problem. I think the emphasis will be on manufacturers, but it will also be on how we run these projects now and how we engage with the rest of the building about, I'm buried away as a back of house goods lift, I need a signal to the outside world. What can we agree on?
Brilliant, thank you. Phil.
Thank you. With more and more lifts going on the GSM network, especially in like, so stadium and other things like that, what's the risk of the system being overloaded, in that sort of environment?
Yeah. So the biggest concern we always used to get was people asking us about how we could get signal. The two biggest concerns now are network congestion and the likelihood of the security services turning the network off when there's major disasters or issues and so on. On the latter, you'll be unsurprised to know that security services don't want to talk to the lift industry about how likely it is they'll switch it off. What I can say on that latter one is the last two times it was done was the July 7th bombings and the Manchester Arena attacks. In both cases, it was felt that hampered the rescue efforts. When it comes to network congestion, we will to a certain extent always be at the mercy of what the telecoms networks do. There are various things you can do now with the provisioning of GSMs and the design of them to a certain extent to mean that you're not tied to a single provider. So the ability to move across multiple providers is key here, because if you've got a SIM card that's steered to a parent, you are going to be reliant on how many other people from that parent are around you. The other thing comes back to the ability to monitor things like signal and send a real-time alert if signal does go out. One of the things that GSM brings to us is the ability to understand and interrogate that device and get a much better level of insight around the connection than we ever had on the copper line.